So in 10.5, we took all of our different types of segments and lines in a circle and looked at how to find angle measures. In section 6, we're taking all of those lines and segments again, but this time we're looking at how to find segment lengths. When two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of the chord. So theorem 18 is our segments of the chord theorem, which says if two chords intersect in the interior of a circle, then the product of the length of the segments of one chord is equal to the product of the lengths of the segment of the other chord. So basically, we can take EA and multiply it by EB and then set that equal to EC times ED. So we're just multiplying the parts and setting them equal to each other. So in 1 and 2, we're just solving for x. So we're using that theorem that we just talked about. So we're multiplying the parts of our chords, the segments of our chords. So 3 times x is going to equal 6 times 4. So 3x equals 24. I divide both sides by 3 to get 8 for x. And I'm going to do the same thing in number 2, but I'm multiplying 2 times x plus 1 and 3 times 4. So I'm going to distribute my 2. 3 times 4 is 12. I subtract my 2. I divide by 2. And I end up with 5 for x. So when we talk about tangents and secants and their lengths, if we have a tangent segment, then it only intersects the circle at one point. So it's just that whole tangent segment, which would be PS in that diagram. But when we have a secant segment, that intersects the circle at two places. So we have a chord in the circle, and then we have the portion of the segment outside the circle. So the part of the segment that's outside the circle is called the external segment. So PR is our entire secant segment, but PQ would be the external portion of segment PR. So theorem 19, segments of a secant theorem. If two secant segments share the same endpoint outside of a circle, then the product of the lengths of one secant segment and its external segment equals the product of the lengths of the other secant segment and its external segment. So when we have two secants, what we're going to do is we're going to do EA, or the external portion, times the entire secant EB, and we're going to set that equal to EC, the external portion of the other secant, times ED, the entire secant. So in number 3, we're solving for x. So the outside portion, 6, times the entire thing would be 9 plus 6, or 15, equals the outside portion of 5 times the entire segment, x plus 5. So 6 times 15 is 90. I distribute my 5 to get 5x plus 25. I'm going to subtract my 25 to get 65 equals 5x. And then when I divide by 5, I end up with 13 for x. And then I'm doing the same thing for number 4, but it's going to be a little bit more involved in the multiplying. So I've got x plus 1 times this whole thing added together. So x and x is 2x, 1 and negative 1 is 0. And then the outside 3 times 3 plus x plus 2, or x plus 5. So I'm going to distribute my 2x. So 2x squared plus 2x. I'm going to distribute my 3x plus 15. And remember, when I have a x squared term, I got to move everything to one side. So I'm going to subtract my 3x, and I'm going to subtract my 15. So I have 2x squared minus x minus 15 equals 0. So this is the trickiest part of factoring. So we got to multiply the 2 and the negative 15 to get negative 30. And then I need 2 factors of negative 30 that are going to add to negative 1. In this case, it's going to be negative 6 and 5. So I'm going to rewrite negative 1x as negative 6x plus 5x. And that's okay, because negative 6 plus 5 is negative 1. So I still have my negative 1x, it's just written differently. So I'm going to group my first two together and factor out what they have in common, which would be a 2x, which leaves me with x minus 3. I'm going to group my second two together and factor out what they have in common, which would be a 5, which leaves me with x minus 3. When those two are the same, you did it correctly. So your two factors are that x minus 3 and then what you factored out. So if we set those both equal to 0 and solved for x, we would end up with 3 and negative 5 halves. But we don't want a negative side length, so we're not going to keep that negative. We're just going to use the 3. So theorem 20, segments of a secant and tangent theorem. So if a secant segment and a tangent segment share an endpoint outside a circle, then the product of the lengths of the secant segment and its external segment equals the square of the length of the tangent segment. So basically, we're going to square our tangent, and then we're going to take the external part of our secant and multiply it by the entire secant. So in 5 through 7, we're just solving for x. So our tangent is x, so we're squaring that, and it's equal to the outside portion of our secant times the whole thing, which would be 4. So x squared equals 4. To solve for x, we take the square root, which is just 2. So in number 6, our tangent is 7. So 7 squared equals our outside portion of the secant, which is 5, times that whole secant, which would be x plus 5. So I'm going to distribute my 5. 7 squared is 49. 5x plus 25. I'm going to subtract 49 and 25 to give me 24. And then divide by 5, which generally you want to leave it as a simplified fraction. So this one would just stay as 24 over 5 for x. And then number 7, our tangent is 12, so we're going to square 12. The outside portion of our secant is x, so we're going to multiply that by that x plus 10. 12 squared is 144. I'm going to distribute my x. And remember, when we have an x squared term, we want everything on one side. So I'm going to subtract my 144. And I'm looking for 2 factors of 144 that are going to add to 10. So if I go through my factors of negative 144, if I use negative 8 and 18, that's going to multiply to negative 144, and negative 8 plus 18 is 10. So x minus 8, x plus 18 would give me 8 and negative 18, but I don't want a negative side length, so I'm just going to keep the 8. All right, so last one, number 8, we want to find the radius of an aquarium tank. So we have an aquarium in our picture. We have a tangent of 20. We have an outer secant of 8, and then a diameter, which is broken down into 2 radii, so r and r. So we're going to do 20 squared equals 8 times this whole secant added together. So r plus 8. Or 2r plus 8. So 20 squared is 400. 8 times 2r is 16r. 8 times 8 is 64. So I'm going to subtract my 64 to get 336. I'm going to divide by 16 to get a radius of 21 feet. So if you have questions, let me know. Homework's ready to go on Big Ideas.